Hello, my lovely Year 12 students. It is really great to give you your first um, isolation research method session. Woo-hoo! Yes, I'm sure you're ready to go. So let's get started. This session, we're going to be focusing on peer review. Now, you may be asking yourself, what is peer review? That is a good question. But let's start. Where does it fall in within the scientific process? Now, just because a researcher carries out a piece of research that they are convinced will change the world, researchers, be it in any of the sciences, actually, researchers and scientists in any different subjects will all want to have that groundbreaking theory or that groundbreaking piece of research that will change the whole scientific way of thought. But it's not that simple. Just because you've done the research doesn't actually mean it will be accepted by the scientific community. Now, as you already know, a key aim of science is to produce a body of knowledge through a collection of empirical data, which is obtained through scientific testing. We want this body of research to be able to support all our theories. But we can't just do the research and presume it will support it. It needs to go through a process of further validating to check that this research is true, it is worthwhile. It is important for it to go through a regulated process to ensure it will be accepted by the scientific community and to be published in a recognized and appropriate scientific journal. To get into, for example, the British Psychological Society, you can't just do a piece of research and think, oh, I found the answers. No, it needs to go through a validating process because we've got our British Medical Journal, we've got British Physics journals, we've got the British Psychological journals. They all want to be able to keep a high standard because they too have a reputation to guard. They don't want to be seen as publishing research which is actually in a little while time to find out to be untrue, to be fraudulent, right? So it's really important. So this process is known as peer review. So with regards to the specification, you need to know what it is, you need to know its key aims, you need to look at some of the problems it can come up with, and also its evaluation. So what is peer review? That's a great question. Thank you for asking. Now, peer review is the assessment of the scientific work by experts in the same field. We want to be able to have people that are in the same field. So, for example, a cognitive psychologist who is researching into perception or looking at cognitive biases, you would want another expert in that field to be able to review it. And the reason why we want an expert, because they need to understand what's going on. Peer review is to ensure that the research has been conducted properly, effectively, and what it's found out is correct, but also what is going to be published needs to be of a high quality, because otherwise it won't get into the appropriate journals. And also, peer review is an essential part of the scientific process. It's an essential part of validating the research that's been carried out. Now, there are three main purposes to peer review. The first one is peer review helps public bodies decide which research is likely to be worthwhile. And what do we mean by likely to be worthwhile? I've put here, it helps with the allocation of funding. They want to be able to see the articles that have already been published by this research body and that it's gone through this process, And to be able to say, yeah, well, actually, they're producing good stuff. It's been validated. It's gone through the process of peer review. Actually, if we give our money to them to help them do further research, we're more likely to see the results. Or the idea is that it's going to be worthwhile. They're serious about doing the research, and there's nothing fraudulent with regards to them. Another main purpose: research is published in scientific journals. Peer review is used within these journals in order to prevent faulty data from entering the public domain, the process of validating. In order to get into the most appropriate journals, so if I've done some psychological research and I want my work to be published in the British Psychological Society, which has such a high status amongst all scholars of psychology, they want to publish the best research, the research that doesn't have faulty data. They don't want themselves to look like they're validating stuff that perhaps could be regarded as a pseudoscience, a false science, because that will take away their credibility as well. So scientific journals require this process of peer review because it's part of the scientific process. And the third main aim is to find improvements and amendments within it. Because sometimes when you get a fresh set of eyes examining it, they may pick up on small tweaks, faults, and worst case scenario, actually question the whole thing. So it is really important that the reviewers, again, like we know, are experts in a similar field so that they can look through this with a fine-tooth comb to look to see if there are any corrections, any improvements, anything that needs to be changed, but also to identify in worst case scenario that actually what is producing is very low quality, it's not objective, and therefore can actually be taken away out of, or prevented, should I actually say, getting put into the public domain. Now, this part really isn't part of the specification, but you could actually turn it into a nice AO3. But it's also for all you budding A-level students who are going to go off to university, or you are doing coursework for your other subjects, is peer review and the internet. I thought I'd just throw this one in because it's really worthwhile. Now, the internet, you all know it, you're on it now listening to this. The internet doesn't require peer review. It's one of the reasons why I don't like Wikipedia. Wikipedia said it is reviewed by its peers. So you all think, oh, it's peer reviewed. But the peers is the normal everyday society, the people within it. Now, what we've got to remember that there is vast amount, and actually, is it all truthful? That's why I always say, be careful of your sources that you're using on the internet. Just because it may sound that it's actually, oh, it's using all these big words, it might just be somebody's opinion. So due to the sheer amount of information on the internet, we need solutions to maintaining quality of the information. How do we? Scientific information online is policed by readers who decide whether the information is true or not. Then they post comments or edit the entries. This is the problem. You can do a piece of research, you can publish it straight away onto the internet. So really, you're bypassing the scientific peer review process by getting an expert to examine it, to make sure it is valid, and all that process. But you can just publish it straight onto the internet. Thing about Wikipedia, there is such, oh, I do, you know, if I want to giggle, I'll nip on and I'll read off some of the psychology and I'm thinking, whoa, that's not true. But somebody's validated it. And they validated it refers to anyone who's reviewing it. Yeah, well, that sounds right. They've got big words. Yeah, this must be true. But they're not experts in their field. And this is a problem. And this is why you can turn this into an AO3. You can talk about scientific research, or what we call, inverted commas, scientific research. It's getting published straight onto the internet without bypassing the rigorous process of scientific peer review. And that becomes a problem. It is a major problem. So please make sure when you're doing your coursework and when you're off at university, you're using sources that are valid. They've gone through peer review. Make sure it's from a proper journal, not just off some website on the internet. So although peer review is essential, as it's what distinguishes fact from what is speculation, there are some criticisms about the processes. So here we're moving into some AO3 territory. So let's look at 5 quick things to help evaluate it. So first one, ask the expert. Not always possible to find an appropriate expert to review the research. That is a problem, because maybe you're doing a piece of research that is very niche, or it's a brand new area that's been investigated. No one's done it before. We don't have an expert. Sometimes this can slip through the grid, in the sense it may be passed or refused because the reviewer didn't understand it. They might have think, oh, it sounds right, I'm going to pass it, or don't understand a thing about it, I'm not going to pass it at all. Passing it because they don't know is a problem, because it's not been thoroughly checked. If it's the person doesn't know, they refuse it, and it doesn't get published, actually we could be missing some really important scientific knowledge here. So it's really important we get the expert, but it's not always possible. Moving on to our next ones, reviewers are usually anonymous. Now that's the nice thing about peer review. You do not know who's reviewing it. They don't know who your work it is, and you don't know who's reviewing it. So that anonymity is really important. Anonymous. And that's why when it's anonymous, they can be honest because they know there's not going to be any repercussions back to them. However, the person who is reviewing it, yes, even though they're anonymous, may actually kind of think, so, hold on a second, I'm researching this, they're rivals to me, and actually they might chuck it out, send it back for rewrite, prolong it until they get theirs published. So that is a major problem. Moving on to our third quick evaluation. Our journals, our scientific journals, do like the positive results, the ones that find things, right? They like those. They want to be seen publishing the new research, the new theories, the new amendments to theories that we have. And actually, it does result in a bias, publication bias, because they're only publishing. Don't you think the scientific community has also got the right to hear about the things that didn't generate positive results or challenges existing ideas? So there is a problem there. Moving on to our fourth one. When people review peer review, they tend to positively view research that supports the current theory rather than non-conformist research. This shows change down even more as science is resistant to large changes in opinion. They like any other genre, science likes to keep the status quo, the key ideas of the time. They don't like things that challenge the key view of the time. If you go back in time when they used to think the world was flat, and then somebody came up with the idea, hold on, actually it's round, Nobody had believed them for a long time. They were laughed at. They were shown. They were shoved out of that scientific community because they were bringing ideas that challenged it. And that is a problem. Sometimes they'll reject that research because they don't want to change the existing ideas. And our last little one, once untrue results have been published, they stay in the public view and may be used in debates, etc., even when the findings have been discredited. That is a major problem. We have a lot of fraudulent or pseudoscience, false scientific research. That's what pseudo means. Pseudo means false, but it looks like science. Once that's out there, if that false information is out there, it's in the public domain. People start believing it because they'll think it's gone through the peer process. It must be right. Let's use it in our evidence to challenge things. And meanwhile, it's wrong evidence. So when it comes to understanding peer review, it is an really, 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 really important part of science. It helps give that final validation to the research that's been going out there. And it makes it worthwhile being published. Now, what I'd like you to do, remember there is a worksheet with an additional resource. I'd like you to work through that worksheet using your textbook and the additional resource to develop these ideas further. Have fun doing it.